Okay, number 6. We get to use a graphing calculator for this problem. The first derivative of the function f is given by f prime is equal to cosine squared of x. Now recall again, cosine squared of x, when you're punching it into the calculator, you want to punch in parentheses cosine of x and then square that. Divided by x minus 1/5, how many critical values does f have on the open interval? 0 to 10. So again, critical values or critical numbers happen whenever f prime is 0 or undefined. So since we already have the graph of f, all I need to do is solve for when cosine squared of x over x minus 1/5 is equal to 0 on the open interval from 0 to 10. Now that's significant because here we're dividing by x. If x was 0, this would be undefined, but we're not including 0 on that interval. So what we're going to do is break out our graphing calculator, graph this function, and so let's go ahead and do that. So I'm going to go to y equals. I'm going to create a fraction. We do that by hitting alpha, y equals, and then option number 1 is a fraction. So again, I'm going to go parentheses, cosine, which opens the second parenthesis. Type x, close that one, and then close the cosine and square it. Divided by x, get out of that, minus, I'm not going to do the whole fraction thing. I'm just going to go 1 divided by 5 here for the 1/5. Now I'm going to my window. We're only interested from 0 up to 10. Now, there's, I think, something to be said for doing from -1 to 11, just so that if something significant does happen at 0 and at 10, then we'll actually be able to see it rather than being on the very, very, very edge of the screen. Now, as far as my y, I don't care how high and low. All I care about is where this hits the x-axis. So I'm going to go ahead and leave that y min and y max right there, and we're going to go ahead and graph it. And so here we are. We're looking at this graph. So the question is, where does this hit the x-axis? Where is this equal to 0? And we have 1 time, we have 2 times, we have 3 times. We have what looks like it maybe could be. And just, you might say clearly not because it looks like it's below, but there's no problem with zooming in. And we're just going to go ahead and put this cursor right there. So we're looking like it's 3 at this point. But if I hit enter, there we go. We can see it is definitely below the x-axis there. So we have 3. All right, number 7, the derivative of f is given by f prime. So again, we're given f prime. How many points of inflection does the graph of f have? Well, we have points of inflection wherever f prime, so there's 2 different ways of doing this. We have a point of inflection wherever f prime changes from increasing to decreasing or vice versa, or where f double prime is 0 and changes sign. So I could do this 2 different ways. I can just graph the graph of f and find out where it's changing from increasing to decreasing, or I could actually find the second derivative and graph that. Well, if I don't have to find a derivative, I'm happy there. So I'm going to go back to my graphing calculator, get rid of this function here. Here I need x squared times cosine of x squared. Now, we're going the window and we're going to go -2 to 2. So I'm just going to go -3 to 3. I always give myself a little bit of a window. Here, though, I do need to know how high and how low this graph goes because we need to see where it's changing from increasing to decreasing. So I'm going to go ahead and I'm just going to give myself a -10 to 10, and then I can go back here and adjust in just a second. And looks like -10 to 10 works perfectly. So here we go. Where does it change from increasing to decreasing? Now, remember, I'm looking -3 to 3, so I do need to see. So I'm going to hit trace, and I'm going to punch in -2. And it's going to take me to where -2 is. So these humps on either end, these maximums, relative maximums out here, are not in our interval. Okay. If we want to go ahead and adjust that right now, -2 to 2, maybe that would make that a little bit easier. That's totally up to you. Okay. So we're looking where we change from increasing to decreasing or decreasing to increasing. So right here at this point here, we are changing from decreasing to increasing. So there's 1. Increasing to decreasing, that's 2. Decreasing to increasing is 3. Increasing to decreasing is 4. And decreasing to increasing is 5. So we have 5 points of inflection for the graph of f. All right, number 8. The graph of f is shown above. Which of the following could be the graph of the derivative of f. Right? So personally, what I do a lot of times here is I look for those maxes and mins. So we have like a minimum here, or that is where the graph is approaching a horizontal tangent line up here, and approaching a horizontal tangent line here. That means that f prime is going to be 0 at A, 0 at this point here, and 0 at B. So if I look here, 0 at A, 0 at B, 0 at A, 0 at B, not 0 at A, and not 0 at A. Yep. So we've eliminated two possibilities. Now, what's the difference between A and B? This graph is positive, then negative. This graph is negative and positive. So what does that say when f prime is positive? That means that f is increasing. And sure enough, this graph of f is increasing from A all the way to this point right here. Therefore, since f is increasing, that must mean that f prime is positive, which eliminates C, and so A is our answer. Number 9, the function f is given by f of x equals x to the fourth plus x squared minus 2, which on which of the following intervals is f increasing, which means again, i.e., that is to say, f prime is positive. So we're going to go ahead, we're going to start with f prime of x. That's 4x cubed plus 2x. And so we're going to find out where that's 0 to find our critical numbers. We're going to take out a common factor of 2x. That leaves me 2x squared plus 1 is 0. And so this is going to be 0 when either 2x is 0, which happens when x is 0, or when 2x squared plus 1 is 0. And so we solve this. I subtract 1. I get 2x squared is equal to negative 1. Divide by 2. I'm going to come up here. X squared is equal to negative 1/2. And we should note at this point that anything squared is never going to be negative 1/2. So our only critical number here is 0. So when I do my number line, I'm just putting 0 on here. Now let's go ahead. Let's take a number less than 0, like negative 1. When I put it into the derivative, this piece here, let me change the color here, this factor of 2 times that becomes negative. And this second factor, you're squaring a number, multiplying it by 2 and adding 1, you're always going to be positive. So that means f prime is negative here. And if I plug in a positive number, this piece becomes positive, that's positive, and therefore f prime is positive, which means the function is increasing on the interval from 0 to infinity. All right, let's take a look at number 10. Let f be the function with the derivative given by f prime is equal to this function here, on which intervals is f decreasing. So in other words, where is f prime negative? So again, we're given f prime. So I just need to figure out where is this piece here equal to 0, or where is it undefined? Okay, so immediately we look and we say, well, the x squared is always going to be defined, but this 2 over x is undefined when x is 0. So that becomes a critical number there. All right, so how do I solve something like this here? There's a few different ways you can do it. I've seen people add the 2 over x over to the other side. Oftentimes what I do is this, I eliminate my fractions right away. So since we're dividing by x, I'm going to start by multiplying everything on both sides by x. And when I do that, that gives me x cubed minus, and when I multiply the second term by x, the division by x and the multiplication by x cancel, just giving me 2. And on the right-hand side, x times 0 is 0. So I'm going to add 2 to the other side. And so then x is the cube root of 2. So we have 0, and I have some weird number, cube root of 2. So this is what times what equals 2. So in terms of what this value is, I know it has to be bigger than 1. Because if you take a number smaller than 1, like even 0.9, and you multiply it by 0.9, you get 0.81, which is smaller. So any decimal smaller than 1, when you square it, gets smaller and smaller and smaller. However, I also know it's going to be less than 2 because 2 cubed is 8. So I don't care what that value is. When I choose a number between 0 and this number, I'm going to take a number like 1/2 and let's plug it into the derivative. And so 1/2 squared gives me 1/4 minus 2 over 1/2 is 2, and 1/2, 1/4 minus 2 is negative. So we know we're decreasing here. And I'll be honest with you, I'm going to go ahead and stop, because if I look at the answer, the only one that contains the interval from 0 to √3/2 is C. Under normal circumstances, we would, pursue the rest of it, but that's the only one. So number 10 is C.